So we're looking at AB 28, which is the accumulation function, and this is a big word. This idea of to accumulate. To accumulate means to gather, build up, however you want to say it, build up. But now you gotta keep in mind that in math, sometimes we try to keep things realistic, but sometimes, it also makes sense to build down, which would be like a negative build up or a breakdown. So we could say, how about, let's say that, not build up, down, but let's say build up or break down. And we'll get some metaphors later in how that makes sense. But the idea is it building up or is it breaking down? So this is adding positives, and breaking down would be adding negatives to it. So together with those things we accumulate either positive or negative values. And in particular we're talking about positive or negative areas. So let's get started. The accumulation function. Okay, so we know that we're going to be given this function and it's right below where you guys are talking about. In fact, boom, there it is. We're going to say f of x equals 2. Now, just for argument's sake, it really doesn't matter what this letter is. In fact, that's just a horizontal line, y equals 2, or vertical value equals 2, or output equals 2, f of x equals 2, f of t equals 2, f of k equals 2. It does not matter, it's just a horizontal line. We're used to using x, but today you're going to see why it might be better to use something else. For example, if we are taking the integral from 0 to x of f of t dt, so right here f of t equals 2. This is a line horizontal at 2. And remember that this little symbol right here means find that area, the area under that line to the x-axis or to the horizontal axis. So for the first area that we have, it's asking what is the area in this box right here from 0 to 0 of f of t dt. What's that equal? Well, we know by definition that the area of anything to itself, in other words, a limit or boundaries that do not move, that's just 0. But to visualize that, we're talking about an area of a rectangle that is 0 units wide. Well, that makes sense. If you're 0 wide by however tall, it doesn't matter. But when you multiply by that 0 width, you get 0. All right, let's look at the next one. For this one, we're doing the area from 0 to 1. I'm going to draw that visually up here. That is this box here. And it looks like it's 2 units tall by 1 unit wide. So what is the area from 0 to 1 of f of t? Well, it's 2. And now we're going to build on that. We're going to accumulate. So now let's go all the way, not from 0 to 1, but from 0 to 2. And if we're going from 0 to 2, that might be a little bit hard to read. Let's see if we can darken that up a little bit. Is that how dark that is? All right, let's go, I don't know, purple? Yeah, purple. So now we're going to do from 0 to 2. So this box all the way out. It's not that it's a bigger box, but I'm trying not to overlap lines. So we're going from 0 to 2 of f of t dt. Well, that's 2 units here. This is 2 units wide by 2 units tall. It's just a box. And we multiply those 2 dimensions and we get 4. All right, let's do another one. How about some red action? So now we're going to go from 0 all the way out to 3. And we go up to 2, of course. So now for this area of this box, it's 3 units wide. So we're going from 0 to 3. We're replacing this x here at the top each time. So we're replacing it with 3 this time of f of t dt. And that's going to equal 6. Okay. We keep on building, we keep on accumulating. Now let's go all the way out to 4. So the area all the way out to 4. Now notice we're moving to the right, positive, and up, positive. Positive times a positive is a positive. So this area from 0 to 4 of f of t dt, that is 8. Now for the finale, how many of you can predict what it's going to be? Very good. I know you probably said it out loud and everybody's looking at you like, what does that mean? Well, the integral, or the area, from 0 to 10 underneath the line f of t dt is 10. And notice what's happening here. It's just a simple change each time. We're building this area. We add 2, and then we add 2, and then we add 2, and then we add 2, and again, add 2. And what's really happening is as we go from one box to each additional one, so the first box is worth 2, but then we added 2 more, and then 2 more, and 2 more, and 2 more. So we started out with 0, added 2, did it over and over and over again. This is accumulation, building up. Okay, now why did we say f of t? You know, here's why. Look at this, 0 to x, f of x, dx. Too many x's. Now the f of x dx, that makes sense because that notation is supposed to match. But 0 to x, is this x the same as this? Are these the same? No. No, not really. Not at all. Kind of, not really. Not intentionally. So it's confusing. So we use a different letter. So let's wrap up this part 1 of the video on this next slide here. So now we're going to do the same process, same exact process, but this time we want to build it not with boxes but with triangles. So let's do it. Let's do the first one. Let's start out with, let's pick a color. How about blue? So the integral from, not blue, how about gray? Yeah, gray. From 0 to 0. Notice we're starting at 0, we're finishing at whatever x is. In this case, x is 0. Of f of t dt. This is another easy one. Why? Because it has no height, no width. So that's 0 times 0, double 0, you could say. It's just 0. The area equals 0. Now if we start to build, let's say we're going from 0 to 1. So now we're talking about the triangle from here out to 1 and then up to 1 as well. We're saying, well, what's that area? What's the area of that triangle underneath that line? Well, it's a 1 by 1 triangle, and a triangle is base times height divided by 2, so that's just 1/2. All right, let's go all the way out to 2. Okay, so now when we're going out to 2, we start here and we're going now 2 tall, or 2 wide and 2 tall. And so that's the area from 0 to 2 of f of t dt. What's that equal? Well, it's base 2, height 2, 2 times 2, 4, and then divide by 2 because it's a triangle. That's 2. Lots of 2's. All right, let's switch to purple. So now we're doing the area from 0 to 3 of f of t dt. So we're starting here at 0. We're going all the way out to 3. And we're going to build up to 3 as well. And that means that we have, all right, what are we looking at now? We got 3 for our base, 3 for our height, so that's 3 times 3, but then we got to multiply that by 1/2, so that's equal to 4.5 or 9/2 or 4.5, however you want to say it. Next, all right, how are we getting from 3 to 4? Let's do one more color, green. So now we got a base all the way out to 4 and a height up to 4 as well. So for this one, we're doing the area from 0 to 4 of f of t dt. And that's going to equal, well, we got 4 times 4, but we got to multiply that by 1/2, and that equals 8. So again, what's the idea? You accumulate, you build. Now, if you really wanted to break it down even more, you could see how much did we build independently. So if we wanted to find just this box, you know, the whole red is 4, and this little one is 1/2, so that means we added 3.5 to it. And then we're going to add to that to get from 4 to 9 point, or 4 to, pardon me, 2, whoa, let's take a step back. That's not 3.5. That is, in fact, 1.5. And then we added, to get from 2 to 4.5, we added 2.5. And then we added 3.5 to get to the green. So we're accumulating, we're building. We're about to do this, but not with just one triangle, not with just one box, but lots of boxes, lots of triangles, and even semicircles too. All right, so see you in part 2.